Hi guys, it's Ian from Q-Tips. Today I want to show you a new tool that you can use to visualize the profiles for various surfaces or various lines across a three-dimensional surface, like a topographical surface or possibly a water table, something like that. And it's called the Profile tool, and it is a plugin that can turn on, and then as long as you have a couple of surfaces or one surface really, you can map the profile using this tool. So you'll see in this little example, and this is what I'll show you how to do. I've got a topographical or relief DEM or digital elevation model, as well as the water table. And what I've got here is I've got a little line set up which is showing the profile of that digital elevation model, and then when it intersects with the water table, it shows you where the water table is. So that's pretty much what we're going to get to in this tutorial. So yeah, hang in. I've also got some timestamps in the description for the video down below. So if you want to skip forward to a section that is more relevant to you, go ahead and do that. I'll put the timestamps in the video description. Otherwise, let's get on with that. Okay, so let's set about doing that. And what we need to do is prepare our layers so that we can run those profiles. So let's have a look at the QGIS project that is set up. So this is what we've got. We've got a QGIS project that has the boreholes, the contours. These are 1 meter contours for the study area, and then the urban, which is just base data. We're not going to be using the urban or the OpenStreetMap monochrom layers. These layers, they're just background to give us context. Okay, so we're going to need the contours, and we want to create a surface from the contours. So the idea here is we want to compare the existing surface to the height of the water table. So we're going to look at those two profiles together. So we need to determine what that water table height is. Now if we have boreholes and we know the depth of each of those boreholes, now I'm not talking about the absolute depth, I'm talking about the depth from the surface to where the water first appears, or where the pump crosses, or the pipe crosses the water. So that's basically the depth of the water from the surface. So if we look at this attribute table, we've got our little boreholes with a borehole ID and then a depth. So now this is the water table depth. These boreholes may be a bit deeper, absolute. This absolute depth could be 60, but this is where the water appears. So that is the water depth for that particular borehole. Right, so what do we need to do? We need to determine, we're going to compare two elevation surfaces to each other. So if we have the contours which give us our actual surface, and then we've got a depth, then what we can do is we can assign the actual surface to each of these points, and then subtract the depth to get the elevation of that water table above mean sea level, and then we'll be able to calculate a surface from that and compare those two profiles. So that's what we need to do. We need to assign, first of all, a surface height or a surface value elevation to the points, and then subtract the depth from that to get a water table elevation. So what do we need to do? We need a surface. So let's create the surface from the contours. So we have contours over here, and I'm going to use a TIN Interpolation to create the surface. So I'm going to use this processing tool. I've already got TIN typed in there, so I'm going to select TIN Interpolation. My input layer is vectors, the attribute is contours. I need to add that. The extent is going to be the same as the extent of the contours. Okay, and then the pixel size is going to be 1. And what I'll do is I'm just going to save a temporary file and see if that is created correctly, and then I can take a temporary file and copy it, well basically, yeah, export it to my project folder. So let's run that. And you don't have to have contours. If you already have a raster with the elevation data, you can use that immediately. So I just needed to create my digital elevation model from these contours. Right, so I've got my contours and I've got my new surface. Now I'm happy that that is reflecting what I expect to see. What I can do is just select that new raster, which is a temporary layer, and then just click on my model and see if it corresponds to the closest contour, and it looks like it's interpolated correctly. So I'm happy with that. So what I'm going to do is I'm just going to export this to be a permanent layer. So I'm going to save as, it's going to be a geotiff with it, which is fine. I'm going to place it in my raster projects raster folder. I'm going to call it DEM. Same projection as the input files, which is pseudo Mercator. The size of those pixels can be 1 and 1. And that's it. So now I can say OK. It's going to add it to the map. So as soon as it's rendered, it'll add to the map. We've got our new layer. Now this one can be deleted. So that temporary layer is now gone. We'll at least have a permanent layer for my project. Let's just save this project. So if anything happens, I can at least have my new layer. Right, so now what I need to do is I need to assign values from this surface layer, the digital elevation model, to my boreholes. And it's called, it's a Saga tool called add raster values to points. So here it is here. So add raster values to points. That's my recently used algorithms, but it should be down here as well. So add raster values to points. So that's essentially the same tool. So I'm going to double click and open that. So I'm assigning the values from my raster to boreholes. I just need to make sure I choose the right raster or grid. It's a digital elevation model. Okay. Interpolation is going to be nearest neighbor. And I'll do the same thing here. I am going to create a temporary file. Now in this instance I will delete this file, so I'm not going to create a permanent file ultimately. So I can run that. And it adds a results point file to our project. So if I open up that attribute table, we've got a new surface, which is the DEM. So that's the value from the DEM essentially. So that is the surface height for that particular point. So all I'm going to do is I'm just going to update my existing borehole attribute table. So I want to run a join. So I'm going to go properties. I'm going to do a join. I'm going to join the results, the BHID. This is my unique identifier in both of those tables, and say OK. Now when I open that up, I should have a link, and there it is there. So I want to create two new fields, so I'm going to use my calculator for that, and I'm just going to call this one DEM, or it could be surface. I'll leave it as DEM. And decimal number, that's all fine, and then I'll just calculate it to be the same as the results DEM, which is the imported value. There we go, so 4848, that's what I expect to see. And then the next one I need to create is the elevation of the water table. So let's just call this water table, yeah, let's just call it water table, W table, and I'm going to use the same values, decimal number. Okay, so what I want to do, I want to have that water table height. So it is my actual surface minus the depth will give me the surface or the height of that water table. Okay, there we go. So we can save that and say OK. And then I can just go and remove that join. Another way to get rid of a join is you just go and delete the results table. Whoops, you just delete that layer, and then it should break that join. Okay, there we go. So now what we have is we have an elevation of the water table above sea level. Okay, so all it is it's the actual surface minus the depth to give us the elevation of that water table. So let's go and turn that into a TIN. So we'll use the interpolation, TIN interpolation again. And it's boreholes. In this case, it's our water table. And we're going to also use the layer extent. That's fine. Same pixel size. And in this example, I'm happy that I'm confident it's going to create a correct raster. So I'm just going to save it to my project folder. I'll put it in rasters. I'll call it the same thing. W table. and save and run. Close. There we go. Right, so now we have two elevation surfaces that we can run profiles on to compare the difference in the water table to the actual ground surface. And the tool I'm going to use to do that is a plugin called the Profile tool. But before I do that, I just want to just color up my surfaces just to look a little bit more intuitive. So I want my digital elevation model or surface elevation to be a color ramp, something like that. Just for me, when I work with data, I know that now is a low area, and that signifies a high area for me. Green's low, as in valleys and that sort of thing. And then the peaks are always like almost like snow-capped, if you like. I like that kind of contrast in colors for my elevation model. And then possibly for the water table, I'll do something, maybe just do single band pseudo color. And then let's go have a look in here. There might be maybe this blue here. And then I'll put my lower values as the darker colors. So I just need to right click on that color ramp and just say invert colors and see what that looks like. Okay, so I've got my two layers. I'm quite happy with that. Right, so let's have a look at that tool. So if you haven't accessed your profile plugin tool or your plugin profile tool, you can do that now from the plugins menu. So click on the plugins menu and select manage and install plugins. And if you select all and just type in there profile, you should see one called Profile Tool. Now mine's been installed before, so it may look slightly different to yours, so I just need to turn mine on. But if you select yours and then just click Install, that'll install the Profile Tool, and then we can open it up and see what we can do with that next. So I'm turning mine on. I can say Close, and I get a new little icon over here on my menu, on my icons toolbar, and then I also get a new menu under the plugins menu, and it's the same thing really. So if I select that one or that one, it's the same thing. So let me click on Terrain Profile, and yours might be a floating window. Mine's come through docked at the bottom of my view, which I'm quite happy with. I'll just stick with that. Now there's a few things you can do with this tool. You can compare two profiles from compare the same profile from two different elevation surfaces. So let's do that. So what you'll need to do before you start is just select the elevation surface you want to add to the profile query, and then just click on add, and then it just gives it a default color, which is red. You can select the next one and click add layer as well. Now that's no good if they're both the same color. We want to sort of differentiate between the two. So I'll make my water table one blue. Okay, and then all we need to do is choose a profile. Now you can set a temporary line, so you can just sort of start drawing on your view, and that'll come up with a profile. Or you can actually go and select an existing line or shapefile or vector line that's already in your map as the shapefile to use for the profile. So we can do both of those. So first of all, let's just use this temporary line. So using the temporary line, we've got a little cross on our view, and let's draw a line from this side of our map to this side, and you double click to finish. So I didn't double click there, so I'm just going to start that again. So I want to select my line there and then just double click to finish, and here we go. So now we've got our profile where the red line is the actual surface, the ground surface, and the blue is our water table. So we can see the water table sort of tracks the actual ground surface and gets a little closer to the surface the lower you get. So the lower in elevation you travel, the smaller the distance that you have to drill to get to that water table, which it kind of makes sense. So anyway, that's one way to look at your data, and then you can go ahead and export this as an image, as a DXF. You just select the option you want there and then just click Save As. So let's save it as a PNG. So click Save As. We'll just call it Profile. and you can go and open that and see what it looks like. Now it doesn't really export the highest quality image, but this is something that you can use and work with in an image package if you wanted to go ahead then and edit this and make it look pretty for a report. But it's fairly useful, and it's a fairly decent little tool and quite self-explanatory on how to use. Okay, let's do a different example now where we actually have an existing line. So let's go ahead and create a new shapefile quickly. I'll put it in my profiles folders. I'll just call it profile. Save. It is going to be a line, and I want to use the same projection as my project. I'll just give it one new column. Okay, start editing that, and I'll do the same thing. So you don't actually have to have a single line. You can have a number of different lines. So if we snaked around like this, for instance, if this was a water pipe and you were an engineer and you wanted to see the profile of that, you can basically do that. Let's just add that now. So what I can do is I want to start editing. So start editing and do a similar sort of thing. So okay, right click to finish, and name, what should I call it? Let's just call it profile 1. Okay, I'll save that, and then I'll just color it up differently so we can see it. Make it a little bit thicker and something obvious, nice pink. Okay, so there's our profile. So now what we can do, instead of selecting a temporary line, we choose a selected polyline and then just click on the line we want to choose. Oh, it's panning. I don't want to pan. I want to use this tool here. There we go there. Okay, so now that is a selected line. And you'll see as you scroll across your profile, you'll see the red dot actually tracks the position of where you are on that particular line. Okay, so that's not a so initially I showed you a straight line, and this is a curved line. See, this could be fairly useful for a number of things. If you're a civil engineer and you're planning stormwater drains, you can use this tool to plan the best route for new stormwater drains. Or if you're planning a mountain bike route, you can do a similar sort of thing to see what the sort of trail will be across your profile. Okay, what else can you do? You can look at the table for the actual profile and save that to a clipboard, and then save it in an Excel spreadsheet and manipulate it and view it that way. What else can you do? We can actually, I think I can create a permanent layer. I can create a permanent layer or a temporary layer. So here, so we've already got a layer there, so I won't use this one. So let's go back and pretend we're using a different route. So we're going to go a temporary polyline. I just want to deselect that. I'll turn that off for now. Excuse me. Let me pan across, and I'll just do a straight line across this valley. I'll turn that off, turn those off. Okay, so here's my temporary polyline. I'm going to remove the water table, please. Okay, so I removed that from my little profile, and I'm going to do a temporary layer, and it is going to be, I just need to make sure I choose my tool again. So let's just say we went from this side of the valley to that side. There we go. So you can see the position of the highway. That's actually, there's a highway running here, and then there's a little valley, so you can see where that highway has been cut into the profile of this portion of land or topography. So what you can do is you can then save this as a temporary or permanent layer. So you can save it as a temporary layer, and then it saves basically a new shapefile which is points, and then it's got a record for a record and a position for each one of those values. So there's your elevation values. Okay, so if you select these it would slowly, and it's actually created quite a few here. So let's see how many has it created in total. There's like 1002 points for this short span of land here. So then you can also export this or save it as an Excel spreadsheet to work in a spreadsheet package like Excel, for instance. And that's pretty much the tool, really. It's pretty straightforward, but it's quite a nice little tool, and it seems to be quite powerful in the things you can do with it. So yeah, play with that and let me know how things go. I think it should be fairly useful, particularly if you're doing sort of engineering or geological queries. Okay, so that's it for this video. Cheers.